In this video, we will focus on rational zero theorem. What is this theorem all about? Suppose we have here this function here and we wanted to know what are the factors of this function. In order that we can do that, we're supposed to find the roots of this function, or we need to find the zeros of this function. But how do we pick numbers out there, the one that we can pick as zeros for this function? There's like an infinite numbers out there. Do we just randomly pick 5? Do we just randomly pick 7? Do we just randomly pick 13 or 100 or 50? So that is the reason why this theorem was developed. The purpose for this theorem is in order that we can narrow down the possible roots or the possible zeros of this function. Before we jump into this example right here and before we go into the details of this theorem, let's have a review on zeros or roots of a function. Zeros or roots of a function are values of x that causes the function to be equal to 0. Now, there are some notations how roots are written in some problems. So in some problems, they write it this way. The roots are 5, -3, 2i, 3 plus minus I. In some problems as well, they write it differently. So they write like x is equal to 5. They also write this as x is equal to -3, x is equal to 2i, and x is equal to 3 plus I. And then this is also the other one, since it's plus and minus, so that would also be x is equal to 3 minus I. Now, if we want to change these roots here into its factored form, we are going to use the zero product property backwards. So we can go ahead and rewrite this as x minus 5 in parentheses, which means that if we equal this to 0, then we add 5 from both sides plus 5 from both sides. That's how we got x is equal to 5. So pretty much we switch the sign of this and that would be in factored form. So in this next root right here, we can go ahead and write this as x plus 3. And this one right here can be written as x minus 2i. And this one right here in factored form, we can write this as x minus 3 plus I. And then that's the other one here is x minus 3 minus I. So this is how we change the roots into its factored form. So pretty much the trick is if we are given the roots in either of these notation, all we need to do is to switch the sign of the root, put it next to the x, and put these two binomial inside the parentheses. Okay, so going back to this rational zero theorem, if a polynomial function has an integer coefficients, then any rational zero must be of the form positive negative p over q, where p is a factor of the constant term. So in this problem right here, this will be our p, and the q is a factor of the leading coefficient. In the example that we have here, this will be our q. So we need to determine what are the factors of p and q. So then I can go ahead and write okay, so I need to figure out what are the factors of 3. So the factors of 3 would be a positive, -1. We also have a positive and -3. So those are the two factors. Now let's determine what are the factors of 2. So that would be 1 and 2. So then to determine the possible zeros, this is what we need to do. First, we are going to create a fraction. We are going to use the positive -1 over 1. That's the first one. So I can go ahead and write that down here. So that would be positive -1 divided by 1 is just 1. So I can go ahead and write positive -1. And then I go ahead and pair this up with the other one right here. So this positive -1 will be paired up to the 2 here. So then we can create a fraction, and that would be a positive -1/2. Now, the next thing that we're going to do is we are going to use the 3 as the numerator, and these 2 would be the denominator. So I can go ahead and create a fraction. So that would be plus minus 3 over 1. So then that is just 3, but it's going to be a positive and the negative 3 because you have 3 divided by 1 is 3. And then I'm going to pair this up, the 3, positive and negative 3 with the 2. So then that comes out a positive negative 3 halves. So these are the possible zeros or the possible roots. Okay, so these are the possible roots or the possible zeros of this function right here. So I have both positive, I just separated it, positive and the negative 1, and then we have a positive 1/2, a negative 1/2, positive 3 and negative 3, then we have positive 3 halves and the negative 3 halves. So this function will have these possible zeros. Okay, at this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We're supposed to find all the possible zeros of this function. We remember that this is our P and this is our Q. So then we can go ahead and determine the factors of P and Q. Now we are going to pair them up. So we start with a 1. So that would be 1 over 1 is 1. So that's going to be a positive negative 1. And then we pair up this positive negative 1 with 2 here. So then that would come out plus minus 1/2. And then we pair up the positive negative 1 with 4. So then that would come out positive negative 1 over 4. And then this time around, we go to 2. So that would be positive negative 2 over 1. So that would come out positive negative 2. And then the 2 is going to pair up with a 2. Positive negative 2 over 2 is 1. Positive minus 1, so we don't have to write that. Now we have positive negative 2 over 4 is a positive negative 1/2. So that's covered. Now let's move on to the 3. So I'm going to pair up the positive negative 3 to 2. So that would come out positive negative 3 halves. And then I'm going to pair this up. By the way, I still have to pair this up with a 1 as well, because it has to be all of the denominators. So then that would come out a positive negative 3. And then we have to pair it up as well with 4. So that would be a plus minus 3/4. And then I will do the same thing for the 6. So pretty much on the 6 here, we're going to have positive minus 6 divided by 1 is a 6. So that's going to be a positive minus 6. And then we have positive minus 6 divided by 2 is a plus minus 3. So we don't have to write that. Positive negative 6 over 4 is a positive negative 3 halves, so we don't have to write it. So then these are the possible zeros. Okay, so these are the possible zeros of this function right there. Did you get the same answers as this? Good, perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!